All right, so a thing I didn't realize until I started doing research for a previous version of this talk is just how old service level agreements really are. It wasn't too much of a surprise to find that telecoms were using them back into the 80s and even the 70s to promise a certain amount of reliability of their infrastructure. But what surprised me a bit more is that bank documents were using them back in the 70s and the 60s regarding, here is the time frame within we promise that we'll send these funds when it's owed to you. But the further back I went, I kept finding more and more mentions of service level agreements, including a UN document dating from 1948, only a few years after the UN was even founded. But we can go back even further than that. I found a job listing for a punch card machine operator in Boston in 1926 that used the term. And what was interesting here is that service level agreements was being used to talk about the prospective employees. It was basically saying, if you take this job, you will have to perform in this way on an hourly basis. And if we think just a little bit outside the box, we can probably go even further than that, right? Even before the term service level agreement ever existed, the concept almost certainly did. As long as humans have been exchanging money for some kind of service, there's likely been some kind of assumed level that people want that service to meet. But look, at the end of the day, I'm not a historian, I'm a site reliability engineer. If I haven't met you yet, my name's Alex Hidalgo, and I think reliability is very important. So, the term service level agreement is being used more and more and more, and you're constantly hearing people talk about SLAs and SLOs and SLIs. And this graph is output from Google's Ngram project, which is a project that's scoured centuries of books and magazines and newspapers and allows you to search for how often a term is being used over the course of time. And you'll see that there's this huge spike on the right as we get closer to our current year. But what's even more interesting to note is that this data on this graph is only from 1970 through 2008, because that's kind of when the Google Ngram project stopped. And even if we see this curve spike like this, I think we can probably assume that in recent years it's spiked even further. And why is this? I think one of the reasons why is because we have so many services now. Everything is a service, so we need a way to talk and describe and measure services. I mean, you have platform as a service, and infrastructure as a service, and monitoring as a service, and networking as a service, and database as a service. And none of those even captures our favorite acronym, SaaS, which in and of itself can stand for software as a service, or security as a service, or search as a service, or storage as a service. And even if you don't live in a world where you're outsourcing things or using cloud SaaS providers, you probably operate some kind of microservice architecture, which is services that depend on services that depend on services that talk to other services. It's services all the way down. So how did we get here? Why is it the case that everything is a service now? And I think it's some combination of continuous delivery and microservices. These two things have kind of gone hand in hand in changing how we think about things and how we deploy things and how we run things in the industry. So let's take a brief look back and see which influenced which and what came first. And I mean, a good place to start is Martin Fowler wrote an amazing article called Microservices back in March 23rd of 2014. Oh, but about a year before that, Martin Fowler wrote something in 2013 about continuous delivery. So oh, but in 2012, James Lewis gave a great talk about microservices in Europe. And I can't believe I almost skipped over this. The real starting place clearly is Jez Humboldt and David Farley's Continuous Delivery, published in 2010. A phenomenal book if you haven't read it. Oh, but wait, John Allspaw and Paul Hammond presented a talk about 10 or more deployments per day the year before that in 2009. So maybe that's where we got started. No, wait, right? Because Peter Rogers delivered a talk that referred to micro web services in 2005. The point is, maybe it doesn't really matter which came first or which influenced which. It's the world we live in today. We live in a world of many services that depend on many services, and one of the reasons they're small is because we like to be able to deploy to them often. So instead of trying to figure out what the exact actual literal history is, let's just tell a little story about how this actually develops in the real world. Someone has a new startup idea, and they write an app. At first, it lives on their laptop, Eventually, they probably set it up in the cloud somewhere or something along those lines. And as it grows, they realize it needs to be distributed, right? They can't just have one pod running. They now need 3 or 4 or 10. And because of that, they got to put a load balancer in front of it to make sure that the traffic is routed correctly. And eventually, they realize that there's like the local storage isn't quite enough, so let's add a database. And now the startup's doing well, and it gets its first round of funding, let's say, and some additional engineers are hired. And these engineers are like, that's really cool, but it also needs to do this other thing. And so a new feature is added, and we have another microservice. And then some more features are added, which also have to talk to the database. And you have this other cluster of features that are kind of unrelated. And this just keeps going and going. And suddenly you realize that, okay, all these features are actually kind of doing the same thing. So we probably need some kind of smart proxy in front of these microservices over here. And then you realize you probably need an inbound and outbound proxy for everything to begin with. And a bunch of new features are added, and they all have to talk to each other instead of directly to the main web app. And then you realize that the database is getting too small, so you got to distribute this as well to make sure that, that stays reliable. And suddenly you just have everything intermeshed. Everything's talking to everything else. And this isn't just distributed, it's deep. So now you're trying to figure out, how can I figure out what's going on in my system? I can't believe I let it get to be such a mess. So you start adding some stuff. You add logging everywhere. Okay, cool, now you got a bunch of logs. And then you add metrics everywhere. And cool, now you got a bunch of metrics. And then you add tracing everywhere. And this is all cool, this is all helping you, right? Whereas like logging gives you insight into what a single binary is doing, and metrics can often give you insight into what a service as a whole is doing, and tracing can help you get insight into what like a mesh of services is doing. What do you actually do with all this telemetry once you have it? The data doesn't mean anything if you don't know how to use it. How do you keep a system as messy and complex as the spider web I'm currently displaying? How do you keep that reliable? Because these aren't just distributed systems, they're deep systems. Just last week, Ben Sigelman wrote a great blog post with this quote in it. Architectures with the top and bottommost services are separated by 4 or more hops. These are deep systems. And they get more and more complicated. I don't know if anyone's done the math, right? So I don't know if it's quite exponential, but every time you add a layer, it's definitely not just linear. Things get more and more difficult to measure. So how do you keep systems like this reliable? Well, I'd like to introduce to you what I have in a, I think, clever turn of marketing called the reliability stack. At the bottom of the stack, you have SLIs, or service level indicators. A service level indicator, it's just a metric. It's just a data point about how your service is doing. The best SLIs are binary in some sense. They tell you my service is doing what it's supposed to, or it's not. And the most important part here is that good SLIs, good service level indicators, are measuring things from your user's perspective. Not necessarily what you think is right, but what do the users of your service think it should be doing? And a quick side note, when I say user here, I don't mean just humans. This could be other services. This could be services of other services. This could be robots, right? It's anything that relies on your service. And next to the stack, SLIs inform SLOs, or service level objectives. And as we mentioned before, a good SLI is a binary. It's either good or bad. Because what that allows you to do is say if we take our good events all over total events, that gives you a percentage. And an SLO is just a target for what you think that percentage should be. Or more appropriately, what percentage will keep your users happy. This is also often where you can involve thresholds and get a little more complicated. You can say things like, like the 95th percentile of all my incoming requests should be completed within 200 milliseconds, and the 99th percentile should complete within 400 milliseconds. But the point is, SLOs allow you to pick a reasonable target, because 100% reliable is not possible. Nothing is ever up 100% of the time. And then finally, at the top of the stack, you have error budgets. So an error budget is really just a different way of talking about your SLO. They're not really that different of an actual entity. It's a way of talking about how your SLO has performed over time. Because it's one thing to be able to say, we're currently meeting SLO, we're currently meeting SLO, we're currently meeting SLO. It's another thing to have a more holistic view, saying, over this period of time, how often have we been meeting SLO? The other thing that error budgets give you is just something that's more human understandable, right? Because you got something like 99.9%, what does that actually mean? It's difficult for humans to wrap their head around that. But what is easier for us to understand is that 99.9% reliable also implies we will not be reliable for approximately 43 minutes every 30 days. So we began this talk talking about service level agreements, and they're really just like SLOs. Generally, they're a little stricter, right? You want to meet your objective before you meet your contractually obligated agreement, and that's why they're separate. Service level agreements imply a contract. They imply payments. They imply that you owe someone money or credit or something like that if you can't meet that. And that's why I don't actually speak about them as much. SLAs are much closer tied to the business side of things as opposed to the engineering side of things. SLAs can fuel their own error budgets. They're often informed by the same SLIs as SLOs are. But with all this jargon up on the page, the thing I really want to talk about today is SLIs, service level indicators. Because I think they're the most important part of the stack. And in fact, I would argue, even if you can never get to the point where you are calculating SLOs and you have a good target and you're using an error budget and your burn rate to drive decisions for your sprints to figure out what you should be working on, just having SLIs gets you most of the way there. And since they're at the bottom of the stack, they're the most important because you remove them and everything's going to come tumbling down and potentially catch on fire. So why are SLIs so important? Well, because they are the things that actually measure the reliability of your service. Your SLO targets don't. Your error budgets don't. Your SLI is what tells you, is my service doing what it's supposed to be doing? And your service has one job, which is do what your users need it to do. I don't care if you have 0 errors in your logs. I don't care if your metrics say everything's fine. I don't care if Kubernetes is reporting or your pods are up and healthy and they're not crash looping or anything like that. If the users of your service aren't happy, if your service isn't doing what they need it to do, your service is not being reliable. Uptime doesn't matter here. Availability doesn't matter here. That's not what reliability actually means. And this also means that users define your reliability, right? You don't get to decide it. And that's all a good SLI is. It is thinking about things from your user's perspective. So let's go through a quick little example, something very simple. Right? Here we have a simple web API. It doesn't matter what it does. It's some kind of request and response service. So users send it data, it does some kind of math, and it sends some kind of data back. So what are some things we may care about? Well, we can start off with, is the service up? It's not a bad starting point. The service does need to be up after all. So now we add a little user over here to our diagram, and the user asks, is the service up? Is this API up? And great, like the service is running, except the user can't reach it. So we go back to our list of things we care about. And we got to make sure the service is also available, right? Because that's not the same thing as being up. So now we go back to our user, and our user asks, is the service available? And it is, but it's incredibly slow. So, all right, we got to go back to our list of things we care about again. Now we have, is the service up? Is it available? Is it responsive? What does the latency look like? So we have our user check again, and it's awesome. The service is responding so quickly, but it's only returning errors. So we got to go back to our list again, right? And now we're asking, is the service up? Is it available? Is it responding quickly enough? Is it returning more than just errors? We have our user check again, and this time it's awesome. All 200s, every response is good. Sweet, we're finally there. Oh, but the data format's wrong? Okay, so we go back to our list again. Now, is the service up? Is it available? Is it responsive? Are the responses good? Is the data format what you are expecting, right? Like, if you're expecting JSON and you're getting a protobuf, that doesn't do you a lot of good. So the user checks one more time, and okay, we finally made it. The service returns the correctly formatted data, and it does so quickly. Oh, but it's yesterday's data. So we got to add another thing, and we could keep going and going here, right? Like these 6 things are just a start. We could go much deeper. But you got to make sure all these things are true, right? Otherwise, your service is not reliable. So the user checks again, and finally, yes, okay, we're getting good responses. The data is fresh. It's in the correct format. It's showing up very quickly. Everything's finally perfect. So now we have this list of 6 things we care about. And that's just so much stuff. We got to measure so much stuff now, right? Which gives us a new problem. The new problem, there are so many things to care about if only we could measure many things by measuring only a few. And luckily, you can just measure many things by measuring only a few. Because if we go back to our list of things we care about, the things that actually make our service reliable for our users, well, if you're getting fresh data, that implies that the data format was correct, which implies you weren't getting just errors back, which implies that the service is both up and available. And I'll concede, depending on how you're measuring and what your telemetry looks like, maybe you'll have to measure responsiveness, your latency separately. But even if you do, that's 2 things you're measuring to cover all 6 of these. So an example SLI for this web API we just described might look something like: requests to our API will result in responses that provide fresh data to clients within 200 milliseconds. That's a simple human-read way to do this. And as you'll notice, this is a binary. Either it's doing this or it's not. And what that allows you to do is some simple math. So we have our SLI right here, all of our good events, and we draw a little line because we're doing division, and below this you have total requests, and that equals a percentage. This is how a good SLI can help you very easily inform an SLO target percentage. But now you might be saying, all right, but my system is much more complex than that. So, okay, that's fine. Let's go through the same exercise, but this time let's talk about a general retail website, right? A place that users log in and they buy some stuff and they give you some money for it. So let's build out a very simple version of what this might look like. So again, you have a centralized web app, something that kind of acts as your site server, and this is probably the busiest part of your system, so probably has to be distributed again. And again, just like earlier, since it's distributed, you're gonna need some kind of load balancing solution in front of it to make sure that, you know, like nothing's getting overloaded in one spot. And your users probably need to log in, so now we have a login microservice that we add to the stack. And you probably need some kind of payment gateway, you know, and this shouldn't just be a separate microservice for, like, you know, management, but probably for security reasons. And, yeah, we need a database, too, to probably hold all this kind of data. And you probably want a shopping cart so users can, like, add things to it and hopefully things stay in there. And then we'll add a cloud over here on the left because, like, that represents the internet, right? So what is a thing we may care about here? What would be a good service level indicator for this service? To start off with, we probably got to check the login process. If users have accounts on our retail website that, you know, stores things like the things they purchased in the past and what their address is and, you know, may store some of their payment information and all that kind of stuff, they're going to have to log in. So how do we check this? I mean, we could start looking at the connection between the web app and the login service. We could check for errors there. We could see how that's going. And that might be fine, and it might tell us some of what's going on, but it doesn't tell us exactly what's going on between the login microservice and the database. And that definitely doesn't tell us anything about our ingress traffic at all, right? It doesn't matter if every single request that makes it to our site server web app is handling the login process correctly, and therefore checking the status of our web app and the login microservice and the database, if only 5% of total requests are even making it there, right? So we got to make sure that the load balancers are operating correctly and that our network ingress is working properly. You need to look at the entire user journey. Otherwise, your SLIs don't matter. We got to look at something like this. We got to look at traffic that's sent across the internet is able to be received by our border router and sent to our load balancers and then appropriately sent to some of the web apps, which then is able to figure out that this is a login request, which sends it to the login microservice, which checks the credentials against what's stored in the database, which then says, yes, everything's fine, and it tells this back to our web app, which now tries to render a page showing the user in a logged in state, and this all gets routed back across the internet to the user's browser. That is a good SLI. But now you're saying, okay, but the example you showed us earlier had more than just like 3 microservices. And yeah, that's fine, right? Deep architectures, deep systems get more complicated the deeper you go. The more services you have that speak to more services, that depend on more services, it does get more complicated. You have more things in the path. But here's a little hint. There's lots of stuff that's more difficult at scale. There's lots of stuff that's more difficult the more you add to your system. Things like global data consistency. This is a very difficult problem. Cross-cloud leader elections. When you're dealing with like different APIs, like handling this kind of stuff gets very complicated, very quick. Cache invalidation, that's basically impossible everywhere. Paying for this stuff, the bigger you get, the more it all costs, right? And there's not to mention people. The more services you have, the more software you have to keep up. The more of an infrastructure you have, the more people you need. And then it gets difficult to communicate to everyone properly and to keep everyone on the same page. And like, the point is basically everything is more difficult at scale. But the thing that isn't, taking a step back and looking at things from your user's perspective. So an example SLI for this more complicated retail website may be something like, when clients external to our networks provide a valid username-password combination, the page reloads in a logged-in state. Right? This is doing something that the users of your service actually need it to do. This is the kind of thing that your users need for your service to be reliable. Again, uptime doesn't matter, availability doesn't matter, error rates in your logs or your metrics saying everything fine, none of that matters if you can't do stuff like this. And this isn't actually mind-blowing. Right? These concepts, talking about SLIs and SLOs and SLAs and error budgets, it's kind of new to the world of operations and reliability and the people that keep the stuff running. But if you were to show this to a product manager, you know what they would do? They'd cross out SLI and they'd replace it with user journey. Right? They probably already have a document titled user journeys -service name. Those are your SLIs. Your business probably already knows them. And if you show this to a business person, they'd cross out user journeys and be like, nah, man, this is the KPI. This is a key performance indicator, right? We're all talking about the same thing. Trying to figure out what the SLIs, what you should be measuring for your service doesn't have to be difficult because chances are other people elsewhere in your organization have already figured this out. This is because meaningful SLIs are developed by caring about what your users care about. Not what makes your life better, although I'd argue that this system does, but that can't be your focus. You need to take a step back. Perform interviews, right? Surveys are garbage. People check 1 or 5 or 1 or 5, low, high, whatever. They'll skip the free-form text entry field. Perform interviews, whether it's with internal users, external customers, people who pay you, people who don't pay you. Sit down with them and say, what is our service doing for you? What is it not? What do you need it to do? And you know what? If this is time intensive, compensate them for it too. That's what you need to do. You need to put yourself as far into your user's shoes as possible, sometimes even just by straight up asking your users. Here are some things that you should care about. You should care about, can the user log in? Can the user buy something? Does the search functionality work? Is the shopping cart consistent? Stuff that I will cede you should be measuring, but you shouldn't be caring about, especially not in the terms of SLIs. API uptime, error rates, database query latency. It doesn't matter how quick you think things need to be if they're quick enough for your users. And here are the 3 different groups that I think actually benefit the most from such an approach. First off, of course, it benefits your users. Because if you're measuring things in this way, if you're taking action in this way, it implies that you're taking their needs into account. You're taking a step back and saying, what do they actually need? What do they believe reliable is? What is their experience? But you can end up with happier engineers too. Because if you do this correctly, you don't have to page about all the other stuff anymore. Right? You may still want to open a ticket. You may still want to track down why error rates suddenly spiked or why one of your pods keeps crash looping or whatever it is. But that doesn't have to be a paging incident anymore because that can all be happening and your service may still be doing what your users need it to do. Definitely not a thing you need to be woken up at 3 a.m. on a Saturday for. And your product teams, your business teams, they'll be happier with this kind of approach because suddenly we have consistency across all these layers. KPIs, user journeys, SLIs, they're all the same thing. This is the way you can unify your entire business. And if you ensure that the product is actually being measured for what it's supposed to be doing, this means all these people are happier. So you take the time to develop meaningful SLIs, even if you don't get to a proper SLO target and error budget computation and all that other stuff. Start off with service level indicators. Start off with measuring your service from a user's perspective, and you will end up with happier users, happier engineers, happier product teams, and hopefully a happier you. Thanks. All right, we have time for questions if anyone has any. Oh, yeah.
So, how do you handle different teams having different SLIs for services? Because you're saying, do what the users do, but there's 12 different users that are using the same service.
Yeah, so the question is, how do you handle kind of like cross-team service level indicators? Yeah, so there's two things at play there, right? One, each service still has a user that is another service, right? So I talk about this very high-level view of where you got to match the entire user journey, but that's your external users. You also just have users who depend on you. So if you're just responsible for a single microservice and a different microservice, relies on that, you should have your own service level indicator there, and you should be measuring that separately. You don't just want only the highest levels, because individual teams still need to be able to take action when their particular component is not working well. Also, this is because other teams cannot define their SLO target unless you have one, because you generally, and there's math tricks around this with stats, but like you generally can't be more reliable than something that you depend upon. So that's part one. You, as the owner of an individual service, need an SLI just for the other services that talk to you. But that's the easy part, because you can at least say, okay, well, we understand the ownership. How do you get ownership for SLIs that span many different services? This part's not easy, but it is absolutely doable. You need to, this is where you get managers of managers, directors, all the way up to your VP of engineering or your CTO, they need to be involved, right? You gotta say, if this is the system we're using and this is how we're thinking about things, and we think this is a good way about thinking about things because we think about our users and this aligns with user journeys and aligns with KPIs, it's not easy to always make this argument, but maybe the VP of engineering owns this, right? Maybe the director of commerce owns this. That doesn't mean that they have to be responsible for coming up with them, but they need to be the owners of things and say, okay, since we've been exceeding things for this long, we need to change our priorities. Our OKRs this quarter now involve being more reliable versus shipping more features, all that kind of thing. So that's the basic idea. As you go higher level, just the way you have a hierarchy in a company where individual people are responsible for more teams and more different components, those are the people that need to actually own these. All right, anything else? All right, thanks everybody.
Thank you, Alex.